When we are solving for a missing side in a triangle, we begin by labeling our hypotenuse, which is across from the right angle, our opposite, which is across from the angle we know about, and our adjacent. So on both of these triangles, the hypotenuse, opposite, and adjacent are in the same place because the angle has not moved. I know about the adjacent and the opposite in this triangle. So if I look at my ratios, when I know about adjacent and opposite, that means that I will be using tangent. And that is also true for the second triangle. So here's my tangent. And then I can go ahead and set up those ratios. So when I set up the ratio, I know it's tangent of 63 degrees is equal to the opposite is 12 over the adjacent, which is x. However, for my other ratio, it's still tangent of 63, that hasn't changed, but now it is x over 6.1. The steps at this point, because of where x is located, when x is in the denominator, we have an additional second step that we end up having to make sure that we do. But when x is in the numerator, then I only have one step instead of two. So let's see the difference between how we would solve those. So tangent of 63 is equal to 12 over x. First thing I do is multiply by the denominator. So I multiply by x. I get x times the tangent of 63 equals 12. Divide both by the tangent of 63. And this tangent of 63, the 12 divided by tangent of 63 is what I put in my calculator. Remember to make sure that your calculator is in degrees and not radians. And that answer is x equals 6.1. I'll look at the second problem and let's compare and see how they're different. This one is tangent of 63 equals x over 6.1. I'm going to do the same first step, multiplying by the denominator. And I will get 6.1 times the tangent of 63 is equal to x. And when I put that in my calculator, I end up getting 11.97, which is pretty close to 12, which would make sense because then that would match our picture that we have at the top, where the triangles look like they're exactly the same, but it is just the different side of the triangle that is missing. The first thing we want to do on our practice is label the hypotenuse, the opposite, and the adjacent. I know the hypotenuse and I know the opposite, and so I know that I have SOHCAHTOA, and so the opposite and the hypotenuse would mean I'm dealing with sine. So my equation, sine of my angle measure, which is 35, is equal to the opposite over the hypotenuse. Multiply 10 on both sides, and I get 10 times the sine of 35, and this is what I'm going to put into my calculator. Remember to make sure your calculator is in degrees, and when I plug that in, I should end up getting 5.74. We always start off with labeling the hypotenuse, the opposite, and the adjacent. This time I have information about the adjacent and the hypotenuse, so that would be cosine. So I have cosine of 33 is equal to the adjacent over the hypotenuse. This is like that second kind of problem that we talked about on the bell work, where when I move x over, I then have to divide by that cosine of 33. So I'm putting all all of that with the division into my calculator, and I will end up getting 19.08. For number 3, we have the opposite and the adjacent, which means that we're dealing with tangent. So I have tangent of 26 is equal to x over 14. Multiply 14 on both sides and put 14 times tangent of 26 into my calculator, and it will give me an answer of 6.83. On number 4, I have the hypotenuse and the opposite, which means I will be dealing with sine. So I have sine of 60 is equal to x over 16. Multiply by 16 on both sides, and 16 times the sine of 60 in my calculator will give me 13.86. On number 5, my hypotenuse is x, my adjacent is 14. So if I know about the hypotenuse and the adjacent, that's cosine. Cosine of 50 is equal to adjacent over hypotenuse. We'll multiply by x on both sides. So I get x times cosine of 50 equals 14. Divide by cosine of 50. And put 14 divided by the cosine of 50 into my calculator, and I get 21.78. The hypotenuse is not labeled, which means I'm going to be dealing with tangent, because tangent is the only ratio that does not have the hypotenuse in it. And I know the tangent of 61 is equal to the opposite 15 over the adjacent x. Multiply by x on both sides, and I get x times tangent of 61 equals 15. We then have to divide by the tangent of 61 because I need to get x by itself, and 15 divided by the tangent of 61 is 8.31. The last two problems, I'll label my hypotenuse, my adjacent. That gives me cosine. So the cosine of 66 is equal to x over 14. Multiply both sides by 14. And 14 times the cosine of 66 ends up giving me 5.69. Finally, the last problem, I know the hypotenuse and I know the opposite, and so I will be using sine. So sine of 23 is equal to opposite over hypotenuse, multiply by x on both sides, x times sine of 23 equals 13. Divide both sides by the sine of 23. And so 13 divided by the sine of 23 is 33.27.